So, my dear children, today we will study the basics of force and stress. What is a force? Force can be either tensile or compressive. If the force is trying to pull the body, then it is called a tensile force. If it tries to reduce the length, then it is called a compressive force. By applying this tensile or compressive force, it produces internal stresses. The stress is called the internal resistance due to the application of force. Internal resistance inside the body. So when a body is subjected to tensile force on a plane, there will be some internal resistance. Those internal resistance are called the stress. If the stress is normal to the surface, then it is called normal stress denoted by sigma. Such stresses will be normal to the plane. If the stress is perpendicular to the plane, or if it is parallel to the plane, then it is called shear stress, represented by tau. For example, if you are piercing a nail into a surface, we are applying, there is a nail, if I am using a hammer and if I am applying the load to pierce the nail into this surface, I am applying a normal stress. If you are applying a sandpaper or a planing job on this surface, sanding job, sandpaper, if you are using a sandpaper to roughen the surface, then I am using and applying shear stress on the surface. Now, there are three types of loading. First one, axial loading. Most simple load. Axial loading means the load is axial to the body. It acts along the axis. This is a tensile axial loading. If the load acts through the axis in such a manner, then it is called a compressive axial loading. For axial loading, our equation is stress equal to force per area, where A is the area of cross section and F is the load applied. The next type of loading is bending. For example, if a cantilever is loaded, it will produce a bending of the beam, and the bending stress is denoted by sigma equal to m by z, where z is the section modulus I by y. Then we have the third type, that is a torsion. When the body is subjected to torque, rotating parts, then the shear stress is denoted by tau equal to T by Z. T by Z, where T is the torque applied, Z is the section modulus. Section modulus. These equations are given in the data book in equation 2.1a, 2.1b and 2.1c. So, if the loading is axial, we have to use sigma equal to F by A, bending sigma equal to M by Z, torsion tau equal to T by Z. Here we can see that both axial and bending load will produce a normal stress whereas torsion will produce a shear stress. Okay, thank you for watching. Have a nice day.